You've already come a ways on your journey to learn Rust for smart contracts, and it's time to cover some more advanced concepts. Closures are something you should understand, especially to read code. For example, we've already run into them in these kinds of contexts where they're used in parentheses. They're used as arguments to various kinds of functions. And we'll definitely use functions like filter and map in the upcoming video on iterators and beyond. But it's still a more advanced concept that if you feel like you need to solidify other concepts or do some more exercises first, then please go ahead. You can write smart contracts in Rust without ever dealing with closures. Closures are anonymous functions. If you come from JavaScript, anonymous functions. You come from C++, lambdas that can capture variables from the surrounding scope or be fed variables directly. So in Rust, closures always have access to the variables around them, which isn't always true of lambdas and constructs in other languages. But the idea is that a closure is a block of code that is treated as a thing. It can be assigned to a variable. It can be used as an argument. It can be returned from a function. And a closure in other languages is often called something else. In JavaScript, we use arrow functions, which at their simplest form look like this. They're used much more in JavaScript than we will use them in Rust, especially in smart contracts. In Python, they're called lambdas, although you can't have multiple statements, multiple things happening in a lambda. You still can have this single expression kind of lambda function. In C++, they're also called lambdas. And now in C++, the lambda doesn't have access to variables outside it unless you give it this, I forget what it's called, like an access specifier or something like that, that tells it whether it has access to stuff outside of it by value or by reference. Now in Rust, the closure is a block of code that does have access to the variables outside of it, but it is a self-contained block of code in general. Here we have a closure called add1, and it takes x as an argument directly, and then adds 1 to x and returns that. Again, since we don't have a semicolon here, we return x plus 1. You could also add a return type here as you would with any function and specify it's going to return a U32 or something like that. So it's a function, it's just written in a different way. And just like in JavaScript, you pass in the arguments this way. You often have parentheses around the arguments and you have strings of arguments, or you have an async keyword before the arguments, right? Just like in JavaScript, you list the arguments there. In Rust, you put them between these pipes, these straight line brackets. It is acceptable, and you'll often see it done to have straight line brackets with nothing or with an underscore here when you don't actually need to pass in any variables for some reason. So here I've very quickly made a function. It's called add1, and if I pass in 5 to it, the result will end up being 6. Why wouldn't you just write this as a function though? Well, a closure can use or refer to outside variables even if you don't pass them in. It can use constants, it can use other things that are happening in the context of your application, whereas with a function, you explicitly have to declare all the variables you're passing in. However, remember I said we won't use this too much, it's really for reading. In a smart contract context, you might not want to do this. And this is the good stuff. This is why you're here, because this is not very well known. Rust is good at zero cost abstraction or zero effort abstraction, where you have things that are easier to work with, like iterators and closures, but they're not more expensive. They don't cost more computation than if you wrote them out by hand. An iterator is a better for loop. It just is. And a closure is sometimes a better function. However, Rust's compiler can't do the optimizations it normally does, like monomorphization, where it basically writes in closures everywhere, like you wrote them out everywhere, and aggressive optimization, where a closure sometimes is just like a function pointer, basically. It's as if you wrote a function. But Rust can't do that if you're using the outside variables. Or at least it can do that, but it creates a custom, I don't know exactly, but it creates like a struct of its own in order to handle the external variables and so on. That may not be the most efficient. So if your closure is using outside variables, you might not want to even do it in a smart contract. So you don't often see that done. Usually closures in smart contracts are short affairs where all the variables are passed in. Closures can use, and it's not that big a deal if you do it, closures can use or refer to outside variables. Here we have x, it's a string that says hello. And even though I didn't put x in these argument brackets, it's still accessible within the closure. This move keyword is recommended, and I'll tell you why in a second. When I use x here, it does move it. Remember variables and ownership, I'm not referencing x. If I just referenced x here, that wouldn't be a problem. It wouldn't be moved at all. Or if I cloned it, for example. But it is moving x in here. It's being used in the closure as soon as I call the closure, and then x will be unavailable down here. You don't forget your ownership and borrowing rules when using closures, but you can use things outside in closures. Learn is brought to you completely free because of our great sponsors. Neutron, enabling developers to build breakthrough applications and onboard users from anywhere. Osmosis, the premier decentralized crypto exchange. And Obi, the smart new standard for asset management. If you want to become a smart contract developer through this lesson and others like it, head to heretolearn.xyz for uninterrupted course videos, coding exercises, and feedback directly from experts in the industry. So why would you use closures? Well, sometimes we basically have to. The more expressive and idiomatically used functions of Rust take closures as their arguments. Filter and others that we will learn in the iterator video coming up next, very common. What filter does is it lets you take a whole collection of things and filter it down. And there are also functions that let you run code on all the things. And you basically have this very tiny function as an argument in filters parentheses. We could have something like tx and specify a return type if we wanted, and then have curly braces where we have this stuff. We could write it more as a function, like looking like a function, but this is a very streamlined way to do it, where filter for every single transaction, let's say you have a huge transactions collection, you want to filter it down to transactions where the amount of the transaction is greater than some minimum amount, right? So the minimum amount is maybe $500, and you set that somewhere else in your code. You filter, and each TX comes in, and this resolves to a Boolean. If the TX amount is greater than 500, it will return true. If it's not, it will return false. And you'll end up with a collection of just all the trues. So this little tiny function runs code and returns a true, I want inclusion in the filter, or false, I don't, on every element of that collection, so it's filtered down. And this is a zero cost abstraction. It's rather efficient, and it uses a tiny closure. And if you're worried about efficiency, then just use some kind of constant here, which gets overwritten anyway, right? Declare as a constant somewhere up in your headers, and it'll just get written in there, and we won't have that concern. Another example is OK or else, which we saw when working with options. And the OK or takes an error as its argument. OK or else, though, and the or else functions in general, take a full closure. And right now, I'm just taking no arguments and panicking, but you could do anything in here and then return any result, and you'd have access to the variables outside, access to your constants, whatever. You can run code if this option is none. Or if this result is not okay, it's an error. You can run code rather than just puking out an error or doing whatever else, a default that you would do here. And so closures, whenever you see these right here, think closure, get closure into your mind. The code in the parentheses is actually a tiny function that will return something. Now, there are cases where you might want to write your own closures. And I don't mean construct your own little tiny arguments, but write situations where you have functions that are using closures as arguments. This isn't too common in smart contracts again. In fact, I wrote a whole API that wasn't even a smart contract. It interacted with multiple blockchains, APIs, databases, and used cryptography and all sorts of things, transaction inspection. And it was a rather complex service, and I used my own closures maybe like twice. They were pretty high impact changes that made the code more expressive, more readable, more maintainable, and so on. But I didn't use them a lot. And so it's something to be aware of, and you might come up with places where closures really work for you, but you don't have to write it this way. In fact, in this example, which is an example I could fit on a single slide and which is readily understandable, I would never do authorization this way, but you could do it this way with a closure. So let me take you through what's going on here. So here I have this wrapper function, a function that takes a function and runs it, but only under certain conditions. It will only run it with authorization. So I have this delete all users closure. I would never write this way. I don't think it's safe enough, but let's say I delete all users here in this closure, which again looks like a function, but has its arguments defined with these brackets, these pipes, rather than with parentheses, which would be a normal function declaration. So this function will delete all users. I don't want to just call it. So I want to ensure that the user is authorized. So I can call with authorization with my current user's role, and then pass in the function. You see up here that this with authorization function has a generic f, which could be anything by this point in the declaration. And this action argument is f. But then we constrain f and we say f must be a function. So the action, this argument we pass in here, action, is a function of some kind. And we run through here and say, look, if the user role is roles admin, then we run the action. Otherwise, we print access denied. Why wouldn't we just put some kind of if statement down here, where if, basically this if statement down here? Because we might want to have more general handling where we have complex error handling. We log bad, like the user's, unauthorized attempts or something like that. Or we might want to pass in some kinds of standard or vetted arguments here that end up getting passed into the function. We can still pass in arguments into this, these pipe brackets right here if we're passing in an appropriate function that takes arguments. So we might want to do more advanced logic around here. There might be more advanced auth checking that we don't want to clone everywhere, or more advanced handling of more advanced protections around certain kinds of actions, or more advanced handling of rejected actions, things like that. In that case, where we want to take a function and run it in certain ways under certain conditions, a closure might be appropriate. But again, you'll see it. I don't expect you to use it in the early exercises. You could do this a bunch of other ways, and there are ways it applies, but you will definitely use this. I will expect these to be seen in the iterators exercise. So that's closures. You want to learn more about closures. Again, not used nearly as much as arrow functions or similar constructs. But if you want to learn more about closures, heretolearn.xyz/closures, and you'll get an interactive Rust learning book chapter with quizzes and so on, where you can explore closures more. We don't have a special exercise on closures, but if you are at heretolearn.xyz, continue on to iterators. We have a kind of a combined exercise for iterators and closures, where you'll definitely need to be using those mini closures in filter and map and other functions that you encounter in the iterators exercise. If you're not at heretolearn.xyz, go there to check out other videos and see a wealth of other resources around closures that will help you on your way to becoming a Rust smart contract programmer.